This is going to be a weird video. We're going to do a discussion, an educational discussion on electricity and circuit breakers. We're going to talk about line and load, grounding, bonding, and maybe you guys can, maybe it'll teach you something or clarify some things. So let's just pretend, all right, you're in a house, all right? So let's talk about the electrical grid. How does it work? How does it end up from wherever to where to your house? Okay. So let's just pretend we've got either, you've got the substations that are being fed power, but let's just start there. Substations that you see randomly throughout the whole neighborhood or, city, you'll see a random thing with all of those wires and those weird resistors, but you wouldn't know what that is. But you know what I'm talking about. They've got all those weird shaped things with the wires going in them, and then they got the circular cylinders, which would be a transformer. You'll see the transformers along the side of the street, attached to light poles. And so what that does, what are those transformers for? All right, so you've got really high voltage that's being shot down all these lines across on the lights throughout the city, or it's underground, really, really high voltage. And the reason why those wires hanging above you are not stupid thick to think about how you would have to power, how much stuff they're powering, why wouldn't the wire be so thick? And it's because of the free hanging, and so it's the ambient temperature and the fact that it's not, it's just able to. That's the code and whatnot. Look it up. All right, so we've got a really high voltage that's going through the lines, going through the streets, down the streets, hanging above you on the telephone poles, and we couldn't power things off of that without doing something. And that's where those cylinder things that you see every so often on the light poles come in, and that's either there's a step down transformer or a step up transformer. And so you can kind of actually say you had 10 volts. If you had a step up transformer, depending on how many windings, there's going to be two sets of windings. One is going to be less windings than the other, and there's a ratio to get the certain amount of step up or step down. And so you've got the 10 volts going in, and say that it's got a couple of windings, and then on the other side where it's going to leave, you've got 30 more windings, and you can step it up, and it'll change the 10 volts to, say, 50 volts or whatever. And so to get back on, reality, we've got those transformers on the poles, right? And so let's just say we're at 6,000 volts going there. So we've got 6,000 going into that transformer, and they're going to step it down to a usable voltage that homeowner and residential houses use, which would be what? 120, 240. And so the reason why there's always two voltages, 120, 240, like it might be confusing, but no. So 120 volt is literally for all the smaller things, light bulbs, outlets, fans, any plug-in accessories, any single thing, your toothbrush, anything is going to be 120. Now, the bigger stuff that are plug-ins, they're usually going to have a different outlet and plug. So, like what? Your dryer, your oven, your stove. For if they're all electric, your water heater, and those are 240. Okay, and so obviously 120 times 2 is 240. So keep that in mind. For the 120 volt, if you had to get a 120 volts, what do you need to do? And so we'll get back to that. Let's just say we've got the step down transformer, dropping it to 120, 240. And we've got it going to our house. And so there might even be another transformer. It might not be 240 until it gets to the transformer that might be in the development, right? And so we've got it finally stepped down. We're at the house, and you've got the meter can, right? And so that's FPNL bringing the voltage, bringing your electricity to your house, and that meter, that circular thing, can keep track of how much electricity you're using, right? And so when it goes through that, when it goes to that, you're going to have, from FPNL, you're going to have 3 wires. You're going to have 2 hot wires, which would make 240, and then a neutral wire. From FPNL, you're going to have the ground rod to create your ground. Have the ground from them. And so that's in the meter. That goes line and load. Let's talk about line and load. I had the hardest time remembering this. So, what is line and what is load? Line, always think of line as the top, and it's the beginning of something that has electricity going to it that can kind of pass through in a way. Okay? And so when you're looking at the meter, line is going to be at the top. It goes through that circular thing, right? That tracks the volt, how much electricity you're using. And then on the bottom would be your load, which is going to go out to your panel in the house. Okay, so think about this. So, because it keeps switching. So we've got line coming into the meter from FPNL. It goes through the circle. That's line. Comes out, which is load. Goes to what? The panel in your garage or in your house, which is going to have another circuit breaker. And what would that one be? That wire is load at the meter. When it comes out and goes to the circuit in your panel, what did I say? What's top and what's bottom? Line is always on the top, load is always on the bottom. And so it switches. It's not like you got line coming in and then there's no more line. It's load, 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 load. For description purposes and being able to talk to someone and describe line or load, that's, it's important to understand that. So we've got line coming into the meter. Then we've got it going out of the meter to our panel. That's load. We've got the wire going from the meter to the panel on top of the circuit breaker that's in our panel. That would be line. And then basically all of the little circuit breakers that it's feeding is your load. It's a load. It's a load in the sense of, what's a load? Something that is that is taking power, that is needing power. You're putting a load on FPNL. On the actual grid, whatever is being powered at your house is a load. And so that's why it can be confusing, because there's, a load in the sense of it's something that, needs power, but then it's like the top or the bottom in a way. Okay? And so line load, line load, line load, line load. Going to your panel from FP&L, you might not just go directly to the panel in the garage or whatever. You might have a main breaker without any circuits, and you might have two breakers without any circuits coming from the meter can, and it would just have two hots and a neutral, and then another two hots and a neutral feeding both breakers, right? And why would you need two? Think about a bigger house. Think about how many panels some houses have. Some have two panels, right? So you would need two breakers. What's a breaker? What's a circuit breaker? It's a protective device. Basically, that circuit breaker, you've got line coming in the circuit breaker, right? Line, load. So what is this in between? I mean, you can turn it on and off, right? The circuit breaker. And that's basically one of the main reasons why we have that, is so that circuit breaker can also be called a disconnect. And the reason we have those, and they're very important, is because let's say we come from the meter. We've got the meter. We've got line from FP&L coming in the meter. We're coming out of the meter, and we hit a circuit breaker, a main disconnect. We have that disconnect going to a panel that doesn't have a main breaker. It's got circuit breakers, the little ones, right? You want to be able to shut electricity off downstream. And that's where disconnects come in line. You can basically go to the closest disconnect, turn it off. And so let's think about this. We've got our circuit breaker. We've got line coming in, load going out. And the circuit breaker's on. So power's always passing through. Let's say we've got line coming in where there's power always, circuit breaker, and then power coming out. If we turn off the circuit breaker, where is there still electricity and where is there not electricity? So you've got electricity up top because it's not being, it's being fed from the source. So it's coming, it's right here. We turn off the breaker, and so the electricity stops right here because it can't pass through, because basically that breaker, it's connected right here, right? This would be on. And when you turn it off, it goes like this. And it doesn't make that connection right here. Okay, electricity's passing through. That's on. When it's off, up, electricity's bouncing, just trying to go through. It can't. So it's stuck. On, bam, goes through. So I hope that can explain a little bit to you about that. So yeah, you gotta keep going backwards. All right, so I think that's a good enough explanation. So, the ground wire. Grounding and bonding. Okay. So, electricity flows through the path of least resistance. So, basically, a ground rod which is a long metal stick, a long pole that you bang into the ground, deep into the ground, they're like 8 feet long, is going to have the path of least resistance. And that's for safety. It's in case, let's say we shorted out and we touched the wire, the hot wire against something, it's going to flow through the path of least resistance. And so, if we didn't have that, it's going to find the next path of least resistance. And, that's where, like, if you're touching something and you short it out, it might shock you for a second, but it's not going to go, it's going to find the path of least resistance, and you'll be okay. So that's, grounding. Everything needs to be grounded. And so think about it like this. Plastic is not conductive, meaning electricity can't pass through it very easily or at all. It all depends on the material. You'd have to do a testing to check the resistance, yada yada. But plastic in general it doesn't have the resistance is very high to electricity. Okay? Metal has good flow. You can pass through. If you've got, let's say, a metal pipe, and you screw on another metal pipe to connect it, it'll flow. Now, if you've got a metal pipe, and you put a plastic pipe, and then a metal pipe, you're not going to have good flow, or any at all, okay? So, when grounding, it's basically like tying in the strongest ground fault, the ground, which is, path of least resistance, which is the ground rod, and tying in any other, so like, you've got all your circuit breakers, right? You're always running a ground wire throughout all of the house. You've got tons of ground wires, because every single thing that you're hooking electricity up to, you need a ground wire, because if something were to happen, they want the ground wire to be the safety. And so what's going to happen? Well, you got your ground wire and it's hooked up correctly. The electricity is going to flow through that, which is because it's the path of least resistance. And so, you've got a ground rod, a ground bar, a neutral bar in your panel, and basically, like, it's tying them all in. You can have all of your ground wires hooked up on the ground bar, and that ground bar is actually hooked up to the ground rod outside, and so it's all connected, and that's how it has the path of least resistance. That's how it can go. So, now, what is bonding? So bonding, grounding and bonding, very similar, but different. So, grounding. You're going from the ground bar in your panel and hooking it up to a ground, a place you connect your ground on, a receptacle, an outlet, a plug, whatever, right? Okay. Bonding is just basically like you're connecting to a grounded thing. So like, all right, so we've got our metal water lines. They're metal, ran throughout the house. We've got it grounded. We've got a ground wire from the actual panel to the metal water line hooked up somewhere. It's grounded somewhere. Now on the other side of the house, we see the water line, the metal water line. And we have, say, a water heater. And we need to bond it for external, safety issues. You can go from the water heater to that rod, to that pipe, because it's grounded, and you can bond it. And so you're just kind of like spreading the web. It's all grounded in one spot, right? Because we have the ground bar that's 8 feet in the ground. Then we have that going to the panel, which is where all of the little ground wires go from each of the circuits. Which one will be attached and grounding the pipe, right? The metal pipe. Okay. And so that pipe throughout the whole house now is grounded. Okay. So just think of it like that. I'm a little rusty. I don't do any really wiring anymore. I do all of like relays and limit switches and all of that. Transformers, little ones. Do you know about... Sorry. Do you know about pi? Ohm's law. Very easy to remember. It's pi. So imagine a circle. And you basically... So we've got the circle. We've got P up here. And then we've got a line in the middle of the circle. So P's up here, line, I, E, and we've got a line in there separating that, right? So it's like a little T like this with the circle around it. We've got the P up here that's separated by this line. On this side, we've got I, which is separated by this line and this line. So that's separated. P's by itself, I's by itself, and then we've got E over here, which is obviously separated. And so it's very simple in the sense of you just need two things to be able to find the other. So, pi. The P is power, which will be watts. I is current, which is going to be amperage. E is volts. The electricity. So, like, if you look on your coffee maker and it shows that the voltage is 120 volts and that the wattage, the thing puts out, or it's at, let's just say 700 watts at 120 volts. So, let's go back to it. We've got the P up top, I, E. So, we have information for P and E, right? P is, what did I say, 700 watts? So, P is power for watts. So, we've got 700. Then we don't have I, we have E, voltage. What did it say? 120. And so it's basically math in the sense of, okay, so we've got 700 over 120 divide. Let's say we have amperage and voltage. So we've got PIE, so we have I amperage and E voltage multiplying, right? They're right next to each other. It's automatically multiplying. And that's how you would find the other. So let's just start at the beginning again. We got 700 watts and 120 volts. So that's division. 700 divided by 120. I have no idea. That is going to give you how many amps it draws. Okay? And so we've got a device that is, we've got a motor or your air conditioner condenser outside, right? You need to get, you see it's labeled under a 50 amp circuit breaker at your panel. You want to go make sure it keeps tripping. You want to go look at it. On the nameplate, it shows the amperage. This isn't realistic. So anyhow, if you had 3,000 watts and say it's putting out, and you've got 70 amps, so power is watts, you got 3,000 watts, you've got I for current amps, 70 amps, you divide that, that's going to tell you what voltage you're at that is able to give you those that amperage basically. But that wouldn't really happen because we're at a set voltage in a way, unless you're on a variable voltage drive or a transformer that you know can change. But usually it's always 120 or 240. So you're not ever going to find watts and amperage on a nameplate together and not have the voltage. So we want to wire an outlet. So we want to wire a little outlet, and we need to run it from the panel through the walls. We're building a house where we run the wire from the panel through the wall to where the outlet's going to be, and we got to hook it up. Let's start at the panel. So the panel, like I said, you're going to have, all right, first of all, what voltage is a regular 15 amp outlet going to be for? Is it going to be 120 or is it going to be 240? Standard outlets throughout your house that you plug regular stuff in is 120 volts. Okay, so how do we get 120 volts? What are we hooking up to? So we're going to have a circuit breaker, right? A little circuit breaker for that outlet. We put it in. What wire goes and gets hooked up to that circuit breaker? You've got a hot, a neutral, a ground, and you've got another hot that you can use. You're not using all four. What would you need? To get 120 volts, what do you need? You need a hot, and you need a neutral. And what do you always bring that I said that's webbed out? A ground, no matter what. 3 wires, no matter what, for a 120 volt system. Hot, neutral, ground. For a 240 volt system, what are you bringing? 2 hots and a ground. Now, you're going to probably bring a neutral and not even hook it up. So yeah, for 240, you're going to bring 2 hots and a ground. For 120, a hot, a neutral, and a ground. So where does the hot, neutral, and ground go? At the panel, where does it go? Your hot goes to the circuit breaker. You're going to make sure that circuit breaker's off if it's connected on the panel. If you're going to start unscrewing shit, make sure it's off and test and verify you don't have voltage. Okay, so that's the hot wire. Bam. Where's the neutral wire go? What was I saying? There's neutral bars and there's ground bars. I just gave you guys the rest of the answer. Neutral goes to the neutral bar. And the ground wire goes to the ground bar. And that is basically it. Now for the 2 hots, you're going to have, for 240 volt circuits, specifically talking about circuit breakers, and then let's say just any 240 volt outlet, switch, whatever, anything that is being powered by 240 volts from your panel, the circuit breakers are going to look a little different. A 120 volt circuit breaker versus a 240 volt circuit breaker. What is going to be the difference? And what's the difference? So what did I tell you on the 120 volt circuit breaker? What gets attached to the circuit breaker? The hot, the neutral, or the ground? The hot. Okay. What did I tell you 240 volt needs? 2 hots. So you're going to have a circuit breaker that is thicker than the 120 volt. It's basically going to be twice the size. And it's going to basically be 2 circuit breakers that are connected and attached together. And there's going to be 2 places to put wires instead of 1. And so, bam, you're hooking up 2 hots. Your ground wires go into the ground bar. And that'll hook up to the outlet that you would plug into it. You're going to have 1 hot on one side, 1 hot on the other, and then you're going to have your ground hooked up. It's very simple. Very, very simple. Very interesting. I enjoy it a lot. I mean, look at me. I literally just talked for 33 minutes. I hope you guys have a good night. I gotta stop because no one's watching this shit anyways. It's too long.